of factoring. So this first one is basically a shortcut that's called the difference of squares. And to do the difference of squares, you need to recognize perfect squares. Perfect squares, as it says on the note sheet, are numbers that you can get by multiplying another number by itself. And so 1 is a perfect squared because 1 squared is 1. 4 is a perfect square because 2 squared is 4, and so on. And so we just want to start recognizing these numbers, 9, 16, 25, 36, and so on. We want to have them 64, right? 8 squared. And we want to make sure we sort of recognize these. We have them in our notes so that we can see them when they show up. And so anytime we see one of these numbers in a factoring problem, we should start thinking about whether we can use this shortcut. Difference, of course, means subtracting. And so in order for this trick to work, we always have to be subtracting two things that are squared. And so in this one, we have x squared minus 25, which I recognize as being x squared minus 5 squared, right? And so that 25 is the same thing as 5 squared. And so we could factor this the same way we have before. We could set up the generic rectangle, set up the diamond problem, and we would have to be careful because that middle thing is a 0. There's no x term there. And that way would work, but here's a quick little shortcut. What I'm going to do is I'm going to put my 2 set of parentheses, and then I'm just going to copy down what I have up above, except I'm going to copy it without the squares. And so one of the factors is going to be x minus 5, and then the other factor will automatically be the same thing, but change the minus to a plus. Right? And so that's the quick little shortcut when we have a difference of squares. So something squared minus something else squared. And so we sort of look for this pattern. And so here's the next one. This is x squared minus 7 squared. X squared minus 7 squared. And so I'm just going to put my first set of parentheses, my second set of parentheses. Just going to copy it down without the squares. So x minus 7, and then change the minus to a plus. Change the minus to a plus. Okay, so why don't you pause the video for a second and give the next one a try. And after you've given it a try, start it up again and see if you got it right. Okay, so hopefully you gave this a try. And so this is going to be x squared minus 10 squared. And so now I'm going to rewrite it without the squares. So x minus 10, and then x plus 10. So definitely easier than doing the diamond problems and the generic rectangles. Can get a little bit trickier when there's a number in front of the x squared, but the same idea still holds. I sort of think about what I could square to get these, and so this one would be 2 squared x squared minus 6 squared. And so now when I go to the parentheses, again, I'm just going to write everything without the squares. So 2x minus 6. And then I copy it down to x plus 6. Okay. And again, only works when it's a minus here. If it's a plus, this does not work at all. And these have to be perfect squares, things that we can square another number to get. So once again, why don't you pause the video and give these last two problems a try. Notice the very last one is a little bit trickier because of y, but you should be able to follow that same pattern. So pause the video and give those a try. Okay, so here we go. So 9x squared, that's 3 squared x squared. 84 is 8 squared, right? And if we don't remember those, we've got them up on our note sheet, right? There's 64, it's 8 squared. And so now I copy without the squares. I change a minus to a plus, and I'm good to go. On the next one, I have 4 squared x squared minus 2 squared y squared. And so now I copy without the squares, change the minus to a plus, and I'm all set. So that is difference of squares, a nice handy little shortcut that will come up and can make your life easier. Thank you.